Okay, let's warm up with number 4. They specifically said to use the method of cylindrical shells, and they want us to sketch the region and a typical shell. So I'm just going to, this is a pretty simple graph, so I'm just going to practice my drawing skills here. Which clearly needs some practice. And we've got y equals x squared. So just basic parabola. And we've got y equals 0, which is the axis. And we've got x equals 1. So that's a vertical line. Right there. And that would intersect at the point 1, 1. So that's the shape that we're trying to rotate. And we are trying to rotate around the y-axis, so around this way. And since we're using cylindrical shells, our typical rectangle will be parallel to the axis of rotation, so it'll look like that. So there's the region, and again, sort of a typical shell, if I were to be able to rotate that around, would rotate back behind here and come back around front. And one of my rotating shells would look something like that. Okay. The shell has a little bit of thickness, if I can draw a second line here. Okay, you get the idea. And keep in mind our formula for finding the volume of all those shells added up. Looks like this. So this is for rotating around the y-axis. And we'll look at an example in the next video where we rotate around the x-axis. And that just changes everything, right? This has to be dy, this has to be f of y, and that has to be a y right there. But otherwise, the formula is the same. For our particular case, we are rotating around the y-axis, so the original formula fits just fine here. So let's see if we can set this up. So looking at my particular rectangle, I've got a little bit of dx there. Again, that matches the original formula. So I'll do an integral in terms of x. My x limits go from an x limit of 0 to an x limit of 1. Again, keep in mind that's the shape that we're rotating. I know the rotational solid goes out further, but the actual blue shape that we're rotating goes from 0 to 1. So 0 to 1. And then we need 2 pi x, and x is the radius of one of those shells, right? That is just the distance from the axis out to where we are. So that's just x, and that's just part of the formula. And then f of x for us is just x squared and dx, and we're done. The integral is set up. I obviously didn't need my dx way over there. So put the dx right there. Okay, and now this is a pretty easy integral to do. I can just clean it up a little bit algebraically. 2 pi is a constant, so I'll move that out front. And we're looking at the integral from 0 to 1 of, okay, don't need that. 0 to 1 of x cubed dx. And like I said, not a hard integral to do right here. This will be 2 pi 1/4 x to the 4th, evaluated from 0 to 1. So plugging in 0 is going to give us 0, but let's plug in 1. That'll be 2 pi over 4, so pi over 2. When you plug in 1 minus, and when you plug in 0, you just get 0 for the whole thing. So the volume of that entire shape as you rotate it around the y-axis is pi over 2. And we're done. We'll look at a slightly more complicated example in the next video.